Hello, let us look at a second question from year 2009, Form A. So this question talks about the rate at which the people enters the auditorium. So I'm going to give you a little bit of time to read, and I'm just going to highlight a few words here together. Now, first, R of t, that's the first function that's given to us right over here. Now, what does that talks about? It talks about the measures people per hour. It talks about the rate, in other words. And then rate at which the people enters the auditorium. So R of t talks about the rate of the people going into the auditorium. Now, no one is in the auditorium and time t equals 0. That can be the initial condition in one way. And door closes and the concert begins at time t equals 2. Alright, that's another given. So let us look into this one and then try to answer these questions together. A. Find how many people are in the auditorium when the concert begins. That means we just have to collect all the number of people goes into the auditorium from time t equals 0 to 2. In other words, we are looking at this one. Because R of t talks about how the rate at which the people enters the auditorium. If you have to evaluate this one, it will tell us how many people actually have gone into the auditorium. Let's put this one into the calculator. Right over here. So here we have 1380 x squared minus 675 x to the third power. So that's basically what we have. Window 0 through 2. Okay. And I'm going to go for zoom fit, which is number 0. And we're going to get a nice graph that looks like this. So if you wanted to integrate, then second trace number 7, as you can see over here, lower limit will be equal to 0 and upper limit will be equal to 2. Okay, that tells us that number of people who got into the concert was exactly 980. Alright, so that was good. Part B, let us try to answer that one. Here we have find the time when the rate at which the people enters the auditorium is the maximum. So that means when is the rate maximum? In other words, we're trying to look into this particular point when the rate is the maximum, highest. To calculate that, using the calculator, we can simply find the maximum point over here, number 4. Left bound, in the middle, I'm just going to call it as 1. 1 should be the left of the highest point. Right bound, I'm just going to call it as 2. Obviously, it has to be between 1 and 2, as you can see. Guess, yes. So this is the second part. When t equals 1.3629, it was the maximum. Now, find the time. In this case, t equals 1.36. Our justification will be the highest on the graph, and you can sketch this graph, or another way for you to do it is you can consider the derivative of R of t, and then R of t goes from positive to negative. But in this case, since it's a calculator question, given the sketch, that this would be the good enough justification. Number 3, C. The total wait time is given by this function. Okay, now so they told us what the function is, and they want us to find the W2 minus W1 given W prime. Now, how are we going to do this one? This one is this one can be done by fundamental theorem of calculus. The fact that we want W2 minus W1 is simply the integral from 1 to 2 of W prime of t dt. Now, all we have to do is then to put this one into the our expression. So what I'm going to do is this. I'm going to go back here. Now, I'm just going to leave this one as they are, just in case. I have no idea if we're going to be using that later or not. So I'm going to put this one as they are and plug in 2 minus t, or 2 minus x in our case, and then multiply that by, in our case, is y sub 1. We can actually retrieve this whole entire function by going to VAS, meaning variables, y VAS, y variables, function, that's what we're looking for. Yes, y sub 1 is what we're looking for here. So this one times the first function. And just for our convenience sake, I'm just going to turn off the first function. Okay. Now, I'm just going to go for zoom fit once again. 0. Then that's the picture we end up getting. And second trace, number 7. Lower limit will be equal to 1, as it is written. Upper limit will be 2. So that's basically what we end up getting. There it goes. So we end up having 387.5 is the value that we end up getting here. Now, find the total wait time for those who enter the auditorium. Will be our answer. Now let's go for part D. On average, how long does a person wait? Now, waiting can be calculated by W. Now, consider all people who enters the auditorium after. So in our case, average time waiting, average waiting will be simply equal to total waiting by everybody divided by the number of people. Now, we know the number of people because we calculated that from the part A. We can figure out the total wait of time by simply getting W2. In other words, we just have to go for W2 over 980. But W2 in fact can be calculated by this way. 0 through 2 W prime of t dt. The reason why we can calculate it in this way is because when t was equal to 0, meaning when before anything began, nobody waited any time. So in fact, in this case, we are assuming that W0 will be equal to 0. Nobody waited in the beginning of the time, of course. Alright, so we're going to go back to our calculator here, second trace, and we're going to try to find the integral. Lower limit in this case will be equal to 0. Upper limit will be 2. Then we end up getting 760 becomes our answer. So therefore, our final answer becomes 760 divided by 980. Now, just to calculate that, 760 divided by 980. Alright, so that becomes our answer. It's about 0.776 hour per person. That's how much each person would have aided on average. Alright, that's about it. I'll see you later. Bye-bye.